React Native developers, in this lesson, we're going to build our first gesture. So we're going to wrap this card into the pan gesture handler so we can move the card around. And when we release the gesture, we add this nice momentum effect to give it the vibe of a physical object. And of course, when we start the gesture again, we remember the previous position of the card. And we bind the movements, the translations of the card within the bounds of its container. And in the previous lesson, we looked at worklets and shared values. And in this lesson, we're going to look at the hooks that Reanimated 2 is providing us in order to deploy these worklets and animation values in our code. So when you are building gestures and animations, you need to do three things. You need to create some animation values. You need to bind gestures to animation values. So you need to have some sort of communication between gesture handlers and animation values. And finally, you need to assign animation values to properties of React components. It can be animated properties, in the case of SVG, for instance, or animated style for views. And in this example, we're going to use almost all of these hooks. So we're going to create shared values, X and Y, for the X and Y translation. We're not going to use use-derived value in this lesson. We're going to see it in the next one. But use-derived value creates animation values based on some worklet computation. So if your animation value depends on some sort of computation, some sort maybe of conversions or other animation values, you're going to use used derived value. So the value is derived. To bind animation values to gestures, we're going to use animated gesture handler. This provides a really cool API that we're about to have a look at. And finally, you need to bind styles and properties from animation values to components. So let's jump right into it. So here we have our final example, and I'm going to switch to the boilerplate, which you can use in case you want to follow along with this example. So here we have our boilerplate. So the first thing I'm going to do is to wrap the card here into a pan gesture handler. So this part is exactly like in Reanimated 1. Nothing has changed. Actually, there's a small detail that has changed. First and unique child of a pan gesture handler is an animated view. And this is where we're going to assign the animated style, which is going to be the translation of the card. And a small change in Reanimated 2 is that here, we only need to assign on gesture event. So in Reanimated 1, you need to assign to on gesture event the gesture handler and to on handler state change. Here, we only need on gesture event. So let's create the on gesture event. So we're going to use animated gesture handler. So it's actually an object, and the API is quite interesting. So we have a callback for each event, on start, on end, on active. So for instance, on active, and you get two parameters. You get the event values, and you get a context object. The event variable contains all the values of your gesture handler. So in the case of the pan gesture handler, you get translation X, translation Y, velocity X, velocity Y, X, Y, what I think that's it, absolute X, absolute Y. If you were to use a pin gesture handler, you would get scale, you get focal X, focal Y, and so on. And context is a global object, so that is shared between each gesture event. that you can use to make your gesture stateful. Because since you can assign states to this object, for each event, you can remember things. So you can make your gesture stateful. Here, we're going to use it to remember when we start the gesture again, where we were at the last position. So let's create two animation values, translate X and translate Y. So we have translate X, use shared value, and translate Y. And when the gesture is active, we can assign to translate X, remember to read and write a shared value, we need to use dot value. So translate X dot value is equals event dot translation X. Same for Y. Now, these values should be assigned properly. So the last step is to create an animated style based on these two values. And for that, we're going to use animated style. So we're going to create a variable called style. And we're going to use animated style. And we're going to return a style. So here in this case, it's going to be transform with translate X and translate Y. And we need to do the dot value up and assign the style to the animated view. Let's have a look. So here we can drag the card around, no problem. But when I start the gesture again, I forgot where I was. So he always thinks we start from 0, 0. We need now to make our gesture stateful to remember where we were when we start the gesture again. And this is where the context object comes handy to make our gesture stateful. So on start, we have event and context. And so what we're going to do is that we are going to create a offset X and offset Y value, like we did in Reanimated 1. In Reanimated 1, we would create animation values for offset X, offset Y, and remember where we are. Here we can simply, we don't need to create extra animation values. We can simply stay, because these only are needed on the UI thread. So we're going to simply use the context object. So context dot offset X equals translate X dot value. Same for Y. And here we can add the offset to the values. So we're going to add offset X and offset Y. So let me maybe reload. So here I move the card around, and when I start the gesture again, we remember the position. Perfect. And the last thing we can do is when we end the gesture, we can look at the velocity on the X and Y axis to add some nice momentum effect. And so in Reanimated 1, we had 3 types of animations: timing, spring, decay. Here, we have also timing, spring, decay, and here we're going to use decay. So on end, so we're going to need event. We're going to assign translate X dot value to with decay. With decay needs the velocity as parameter. So velocity is event dot velocity X, and you need clamping values. So you need what are the limits for the decay value. So in the case of the X axis, it's going to be 0. And then it's going to be width minus card width. So the width of the container minus the width of the card. And we can do the same for y. So translate y with decay velocity is velocity y, and the clamping goes from 0 to height minus card height. Let's have a look. So you see here, so you have boundaries which are respected, and when we release, we have a nice momentum which depends on the velocity of our gesture. Very cool. So a bit simpler than the way we would do it in Reanimated 1. Here we are just using JavaScript. I'm just realizing here also that when the gesture is active, we are not clamping the value. We are clamping only on end. So if I do this, it clamps. But if the gesture is active, we are not clamping. And you see here it's awkward because then we clamp on end. So we can clamp also. Let me refactor this one. I'm going to call it bound X. And let me create bound Y. So here, perfect. And here we're going to add some clamping. So we're going to clamp from 0 to bound X and 0 to bound Y. So you see now, it looks perfect. In the first lesson, we looked at animation worklets and shared animation values. In this lesson, we have built our first gesture, and that gave us a look of the hooks that are provided to us by Reanimated 2 in order to deploy these worklets and animation values in our React code. First, we need to create animation values using use shared value or use derived value if the animation value is computed from other animation values or some worklet computation. Then we can bind animation values and gestures together using use animated gesture handler. And finally, we can bind animation values to properties of React component using use animated style or use animated props. In the next lesson, we're going to look at transitions. Transitions are the easiest way to animate things in React Native. And we're going to take a look at how these transitions look like with Reanimated 2.